Here is some WebAssign homework help for 11.4. So number 8 converges or diverges this series from 1 to infinity. And you can see that both numerator and denominator are loaded. So I will try series comparison first, but actually we would see that I can come up with a series that is just n to the fourth in the denominator, but then still I would have to, if I draw plus n plus 9, then the series will not be less, it will be bigger. So when you see everything so loaded, it's a limit comparison test. Just look how this term will behave when n goes to infinity, and it will behave as 1 over n squared, right? When n is really, really large, then this is the largest guy in the denominator, and n squared is the largest in the numerator, so we would have approximately this kind of behavior. So I would say this is my b sub n, and my a sub n is n squared plus n plus 9 divided by n to the fourth plus n squared. Okay, so, and then I want to look at the limit of a sub n divided by b sub n. N goes to infinity. So I will have the limit n goes to infinity, n squared plus n plus 9 divided by n to the fourth plus n squared, and then I will divide by bn, so I multiply by flipped bn, so times n squared by 1, right? Okay, so I'm gonna get the limit n goes to infinity, n to the fourth plus n cubed plus 9 divided by n to the fourth plus n squared. So I'm going to have plus 9 n squared. I'm going to divide by n to the fourth, so 1 plus 1 over n plus 9 over n squared divided by 1 plus 1 over n squared. And these terms go to 0, and therefore my limit is 1. So what I have is that the limit of an divided by bn is 1, and therefore an series behaves in the same manner as bn series, right? And we know that bn series is p series. P is equal to 2, and therefore it converges. So our conclusion is series an converges by the limit comparison test, because 1 is greater than 0 and also less than infinity, so we got this a decent limit that assures us that the two series have the same convergence behavior. Now let's do number 10. Maybe I will just start number 10. So what I have here is 2n plus 6 to the nth divided by 2n plus 8 to the nth. And again, we can do limit comparison test here, And when n is really large, so we would say that this is our an series. And the limiting behavior of this series would be, we would say b is equal to 6 to the nth divided by b nth, 8 to the nth, or it's going to be 6 by 8 to the nth. And this is going to be geometric series with the common ratio r is 6 by 8 and it's less than 1, and therefore this series converges. Now let's look at the limit an divided by bn, n goes to infinity. We would have the limit n goes to infinity 2n plus 6 to the nth divided by 2n plus 8 to the nth times flipped 8 to the nth divided by 6 to the nth, right? Okay, so I will just is equal to, yeah, I probably need to finish this, is equal to, so I will have limit n goes to infinity, and I will divide, I will pack 6 to the nth with numerator and 8 to the nth with the denominator. So I will have 2n divided by 6 to the nth plus 6 to the nth by 6 to the nth. It will be plus 1. And downstairs I will have 2n divided by 8 to the nth and plus 8 to the nth divided by 8 to the nth, so plus 1, right? So yeah, it's a little bit messy, but here we have an exponent and here we have an exponent, and these are just linear functions. So definitely this guy goes to 0 and this guy goes to 0, and again we will have 1. When you choose bn as a limiting behavior, a lot of times you will get 1 if your choice is right on the spot. Okay, so we just applied limit comparison test, and our second series again was series that is intimately familiar to us. So we got a limit that is greater than 0 and less than infinity. Therefore, the convergent behaviors of an and bn is similar, and we know everything about bn because it's geometric series and it converges. Therefore, our an series, which is 2n plus 6 to the nth divided by 2n plus 8 to the nth, also converges by the limit comparison test. So you definitely will have to, I will put a problem like this on a quiz where you would have to definitely limit comparison test on the quiz, and you would have to just look at the limiting behavior, and guys, you will get it. Okay, that's it.